All right, let's jump right in. Way out in a neighboring galaxy, there's this incredible cosmic drama playing out. We're going to take a look at one of the biggest, most extreme stars we've ever found, and, well, it started doing something that has astronomers totally fascinated.
So, just to give you a sense of the scale we're dealing with here, this star, WOH G64, is about 1,500 times the size of our own Sun. I mean, just try to wrap your head around that. It is an absolute monster.
And this is really the heart of the story. This colossal star is going through this dramatic, totally unexpected change that has scientists glued to their telescopes. It's transforming right before our very eyes.
Okay, so its name is WOH G64. You can find it in a nearby galaxy called the Large Magellanic Cloud. And the leading theory, the big idea here, is that we're watching its final act before it goes supernova.
Now, to really get what's happening to WOH 64, we first got to understand the wildlife and, the explosive death of stars this massive. Their whole journey is completely different from our nice, stable Sun.
Yeah, here's the main difference. Think of our Sun like a marathon runner. It's slow and steady, built for the long haul. But these massive stars, they're cosmic sprinters. They live fast, they burn unbelievably bright, and they die young in the most spectacular way possible.
Deep inside their cores, they're like these cosmic forges. The gravity is so immense, it fuses lighter elements into heavier ones. It all starts with hydrogen, which fuses into helium, then carbon, just creating heavier and heavier stuff, until it finally hits a dead end, iron.
And this, right here, is the end game. See, you can't get any energy by fusing iron. It actually takes more energy than it creates. So without that constant outward push from fusion, gravity wins. The core collapses in a fraction of a second, and that triggers the titanic explosion we call a supernova.
So, knowing that's the ultimate fate, astronomers have basically turned into cosmic detectives. They're piecing together all these clues from 160,000 light-years away to figure out exactly how close WOH G64 is to that final, incredible boom.
Just to really drive home the size we're talking about, imagine this. If we swapped our Sun out for WOH G64, its surface would stretch out past Earth, past Mars, all the way out past the orbit of Jupiter. We'd be inside of it.
And this giant is getting really unstable. Astronomers are seeing its brightness flicker all over the place, its temperature is climbing, and it's just furiously blowing its outer layers off into space, creating this thick cloak of gas and dust all around it.
These changes aren't just numbers on a screen. You can actually see the effect. The star is literally changing color. As it sheds its cooler outer layers, we're seeing the hotter layers underneath, and that's making its color shift from a deep red towards yellow. And that color change, that is the smoking gun. It tells us that WH64 isn't just a red supergiant anymore. Nope. It's evolving into something way rarer and much more volatile, a yellow hypergiant. So a red supergiant, even though it's huge, can stay that way for a pretty long time. But a yellow hypergiant, that is a star living on the edge. It's a short, violent, and super unstable phase. It's like the star's final, shaky breaths before the end.
And this brings us to the big question, the one everybody's thinking, right? If it's so unstable, it has to be about to go. Is the fireworks show starting tomorrow?
And here's the beautiful, frustrating thing about astronomy. When a scientist says soon, they are not on our timeline. Soon could absolutely mean tomorrow night, or it could mean 100,000 years from now. We know the end is coming, but the universe plays by its own rules. So you might be thinking, okay, if it might not even happen in our great-great-great-grandchildren's lifetime, why are we so obsessed with this one star? Well, because what it's doing right now is unbelievably important.
WOH G64 is basically a live-action cosmic laboratory. We're getting to watch, in real time, a star get ready to go supernova. That's incredibly rare, and with our modern telescopes, we can collect data that helps us figure out not just how stars die, but how they create the very elements that make everything else possible.
And that's really the magic of it all, isn't it? These massive stars are like cosmic alchemists. They take the simplest stuff in the universe, hydrogen, and through their lives and spectacular deaths, they create the raw materials for, well, for everything else. Just think about it for a second. The oxygen we need to breathe, the carbon that forms the basis of life, the silicon in our computers, the iron in our buildings,
All of it was cooked up in the heart of a star like WOH G64 and then blasted out across the universe in a supernova. And this is what connects this crazy, distant event directly to us, right here, right now. That line isn't just some poetic idea, it's a scientific fact. The actual iron atoms that are in your blood, carrying oxygen through your body as we speak, were created in the heart of a dying star, billions of years ago. We are, quite literally, made of stardust.
And what if we do get lucky? What if it goes supernova in our lifetime? Don't worry, it's way too far away to cause any problems. Instead, we would get the single greatest light show in human history. A brand new, brilliant star would appear in our sky, so bright you could see it during the day. Just a spectacular, silent firework going off 160,000 light years away.
So it kind of leaves you with this one last thought. Seeing a star die, it feels so destructive, so final. But from its ashes, from the elements it scatters into space, new stars will be born, new planets will form, and who knows, maybe even new life. So are we really watching an ending? Or are we watching the very start of a brand new beginning?